John, I believe your mic is not muted. You may want to mute it unless you have something to say. Thank you. Okay, I think I'm going to make a start. Stefan is having some issues with his audio. So welcome, folks, to the BESS working group. My name is Matthew Bocci. I'm here with my co-chair, Stefan Lekowski, and our secretary, Mankamana Mishra. This is the note file that we display at the start of all working group meetings at the IETF. I'll just pause for a moment for you to ponder the note well. Thank you. This is the agenda that was the latest update, I think, was a couple of days ago. We'll start with the working group status update as usual, and then we have a fair number of working group drafts and a few individual drafts to go through. Any comments on the agenda? Okay, thank you. So, since the last IETF, we've had a number of RFCs published. Multicast VPN fast upstream failover, interconnect solution for Ethernet VPN, overlay networks, propagation of ARP and ND flags in an Ethernet VPN, framework and requirements for Evpn OEM, and the BGP control plane for the network service header in SFC. So it's a total of 5 RFCs, so well done working group. We have a couple of drafts in the RFC editors queue, the Evpn prefix advertisement draft and the Mvpn MSDPSA interoperation draft. There are a number of drafts with our AD, Martin, and who's reviewing them, and also have gone to wider IESG review. I won't read all of those out. I'll just note that on the first one, the IGMP MLD proxy draft will be updated as soon as possible. Okay. 5 drafts under document Shepherd's review at the moment. The Evpn IRB multicast draft, the review is currently being written. The Evpn virtual Ethernet segment draft, I think there's a status update on that in the slides that Luke will be presenting in the next slot. The Evpn PrefDF draft, the review has been done. It's waiting on the virtual Ethernet segment draft. Evpn LSP ping, the write-up still has to be done by the shepherd for that. And Evpn unequal load balancing is waiting for a dependent document to progress. We don't have anything in our working group last call queue at the moment. What we've been doing is trying to back that off a little bit to prevent overload of Martin. Hopefully we'll be able to get that going again fairly shortly. And we have one draft that we have on our list to be considered for working group adoption at present. That's draft Mahanti BESS weighted HRW. Okay, 4D working group documents. Oh, actually, there's a mistake in them. So, Mahanti BESS weighted HRW was adopted. The Evpn L2 gateway protocol was adopted in April. The deployment guide for IPv4 and LRI to IPv6 next hops in April, and Evpn modes interoperability was adopted in April as well. Finally, a quick update on where we are with our working group documents. A number of them are on the agenda: the redundant multicast source, the RFC 7432-BIS draft, the BGP multicast controller draft, Evpn, SR, P2MP, and Evpn fast DF recovery. For Evpn MHPA, the working group last call is in progress. The comments need to be addressed for that. The Evpn Geneve draft, so this is using Geneve as a data plane within Evpn. Sam has updated the draft. It needs to have another round of working group last call to cover off any other comments from the working group. The Ipvpn interworking draft. So that one, I think that the IDR chairs just posted a review to the list, and there's a number of comments, detailed comments in that, but obviously the chairs and the authors of this draft need to look at. Thank you very much to the IDR chairs for that. The Evpn per multicast flow DF election draft, there's a bunch of comments that are being addressed, and I believe the intention is to go for a working group last call after this IETF. The Mvpn seamless interoperability draft, there's a new version which will be updated next month. Evpn BFD, the draft is being updated, new version is planned for after this IETF. BGP SD-WAN usage draft, we believe there's a new version that's ready. The PBB VPN ISID CMAC flush draft, we understand that there's implementations that now exist of that, and that's ready to progress to the next stage. Likewise, for the Evpn multi-open split horizon draft, that's ready to progress, we believe, to the next stage. The extended Evpn optimized IO draft, from the author's side, we understand it's ready to move forward, but Martin's waiting for the run procedures draft to move ahead. The BGP multicast draft, are there any of the authors that would like to step forward to give us an update on that?
Yeah, this is Jeffrey. I can speak about one. So right now, the security consideration section is basically empty. Once we come up with good taxon for that one, we should be able to move forward.
Great, thank you. The IRB extended mobility draft, that's been updated after a working group last call. We're going to do another short working group last call just to confirm those changes. And Doc has some down references today to other documents, so kind of waiting for those to clear. The Evpn Vpws FXC draft was updated in June. Any of the authors for that care to comment?
Yeah, Matthew. This is Pedro from Cisco. Hey, I think for us, the next step would be a workgroup last call, because see, we've been updating it based on the latest comment. There was something around the how we map the vid, single tag and double tag. This has been addressed with the latest update. So I think that the next step will be asking for workgroup last call.
Right. Thank you. Finally, we have some Yang models drafts, but the progress on those is kind of stalled at the moment. We really need, if those are going to progress, they need some more action, I think, on those. Jeffrey, you are first in the queue.
Hey, this is Jeff Haas. So less so about the L3P model, but the core IDR BGP Yang model, which is effectively a dependency. The BGP Yang model has been getting some targeted focus by the authors of that draft, and it's not done, but is making substantial progress. And a core portion of the work that we've been doing is making sure that module interwork can happen. So we've been looking at modules such as the L3Vpn model to make sure that we can actually apply the extensions in the BGP Yang model to the various BESS models, and that work is moving along.
Great, thank you for the update. Okay, and that, I think, concludes the working group document status update, or the working group update as well. Any other comments on that status update? Nope. Okay, thank you. So with that, I think it's a look for the, well, the main subject is the 7432-BIS. Let me share this. Okay, go ahead, Andre.
Yes, hi, Matthew, Andre Francisco. So I have just two beginning or initial slides covering just very quickly port active draft and the VES draft. So I won't be too long on those. So the port active draft is a mature draft, and we have updated it based on clarifying comments received. So in our view, this draft is essentially now ready for working group last call.
Yeah. Can you hear me now? Is that working?
We can hear you. Yes, thank you.
Oh, okay, cool. Look, Andre, in fact, the working group last call was already raised, and there was a couple of comments to be addressed.
Okay, good. So those were the comments by
from Anup.
I think
the one from Anup,
exactly.
if I'm not mistaken.
Yes.
So as soon as you have closed the comments, we can probably close the working group last call. There was also a couple of issues with the IPR answers, but I need to look at the latest emails to see if we got all the replies or not.
Okay.
Okay. There appears to be a technical glitch. I'm advancing the slides and nothing is happening. So I'm going to try resharing this. See what's going on.
I can talk to the VS while you do that. It's also a fairly simple update.
Okay.
So for virtual.
Well, I think I can get this working again. Let's try that. Okay, let's see if this actually goes forward this time. Aha. Okay, go ahead.
Okay, so for virtual Ethernet segment, it's really just more of a shepherd update. As it moved forward, I think I made some comments basically on just the legibility of that draft. And so the version 7 essentially incorporates some clarifying changes and a new section introducing basically the concept or the terminology of grouping, which was essentially prevalent in the document, but never really given a name. So the version 7 has, a fairly large new section for this grouping part, but there are no essentially algorithm or procedural changes to that 07 update. So in my view, that document is ready to proceed. Okay, so for 7432-BIS, I'll just give a brief history in 20 seconds, right? So the idea for BIS of 7432 first came up, or was really first presented at IETF 104 in the chair update, and it was mainly presented as a to-do list or an errata list as an issue tracker to the working group. And at IETF 109, the consensus of the working group was just to go ahead and post directly a working group document containing an initial version of this to-do list of the working group. And so this was done shortly after that in December 2020. In the spring, this last spring, 2021, I think it was right after IETF 110, I emailed the working group basically asking feedback on that initial 00 version, which thanks to feedback from Sasha, Patrice, Jorge, John, Michael, a 01 version has been posted, and that's what I'm going to be presenting today. So in this presentation, I have 10 minutes. So I won't go into the detail of all the changes, but at a high level, to begin, essentially to help readers with the delta from 7432, I have two options that were added. The first one is a link to the RFC diff tool, comparing, really just a line-by-line diff of every single comma, white space, or whatever change between this version and 7432, for those that really want to go through with a fine-tooth comb. Otherwise, the feedback from Sasha, which was really good feedback, was to add a new section containing a summary of changes from 7432. And this is meant to be a lot more permanent than the RFC diff tool link. And this is the new section 1.1. Actually, about that, I think one of the goals as I'm going through this is to make sure I maintain the section numbering of 7432 because I don't want the number to change. To refer to 7432 old after this draft. So to get started, I think one of the important parts of this BIS is Jorge and John have submitted a thorough review of basically, bridge domain and Ethernet tag versus Ethernet tag ID versus VLAN terminology to update the document, to update 7432 and make sure it's not confusing. So that has been incorporated. The first red bullet here is the new section covering, and this is an important section that's basically backported from VPWS usage, or from Evpn VPWS in 8214, if I'm not mistaken. And so this section and subsection cover the usage of the L2 attributes extended community, but applied to bridging. And so this is the new section 7.11, titled Usage of Evpn L2 Attributes. The second red bullet covers an important new section describing priority handling as effectively as a recommendation to BGP speakers. Mainly the new section recommends these bucketized priorities by proposing effectively a grouping of routes by order of importance versus expected scale into essentially P1 or priority 1, priority 2, priority 3 processing orders. And so this new section 7.12 is one that we hope will help meet better fast convergence goals. So the next important update in red on this slide was to add a section describing a new BDF, designated forwarder elected state, so a backup DF, whereby the 7432 previously DF election algorithms effectively defined a single DF versus multiple non-DFs. Through implementation in the years, basically we found out that there is one particular non-DF that's a little bit more important than the others, in the sense that based on the DF election algorithm, he's basically the next one at bat for DF. So the 7432 BIS adds a new section, or actually just updates section 8.5 to include descriptive language for the difference between this backup DF and non-DF roles to DF election algorithms, and basically proposes that any new algorithm going forward should really define these three states of DF, BDF, and non-DF. Next slide, please. Yeah, so I'll skip straight to the fourth bullet to try to stay within my 10 minutes. The important section here is 15.3, which was, it's a new section, completely new from 7432, but it is incorporating actually other working group IDs. And it describes MAC loop prevention and loop detection mechanisms. So it is a completely new section. And section 19, also the second bullet that has red, specifies the use of domain-wide common block, and defines the use cases for that. Other than that, so in the 1 minute I have left, there's updates to the flow label usage, inclusion of P2MP, LSPs, and so on. A significant update to the document in terms of restructuring, renaming, cross-references, editorial changes. So that's for the fine-tooth comb diff. But other than that, I think the main sections that would require working group review are the ones that I've highlighted in red in these two slides. So the next steps for this BIS, I think it's, I appreciate the feedback that we've received so far, but obviously more comments are always welcome, as this is, it's effectively already a working group document, and it is meant to cover any errata or significant changes since 7432. Thank you.
Great, thank you. Any comments from anyone? I would encourage the working group to review the draft with respect specifically to the new changes that Leandro just went through. Okay, thank you very much. Right. Next up is Arvind.
Hey guys, can you hear me all right?
I can hear you. Just give me a minute to get the slide shared.
Okay. Hello everyone. My name is Arvind, and I'm here to give you an update on this document that describes procedures for delivering Mvpn and Evpn services over an SR network. Next slide, please. So a quick history, the document was originally published in 2019, which included only procedures for Mvpn services. Later in 2020, we added procedures for Evpn services as well, after which the document was adopted into BESS in late 2020. Since then, we had a couple of minor updates, mostly editorial changes and requests for INR code points at this point. Next slide, please. So the earlier versions of the document covered procedures for binding Mvp and Evpn services to an SRP to MPP tunnel. The significant update that's coming in as part of this version is procedures for binding these services to an ingress replication P tunnel in an SR network. We've added sections to cover both SR-MPLS and SRv6. For SR-MPLS, there's really no new additional procedures required besides what's already defined in RFC 7988. For SRv6, we've defined procedures to attach an SRv6 multicast service set to the Bgp Mvpn auto discovery routes. The SRv6 multicast service set will be signaled using the SRv6 services TLV. And to go with that, we've also defined new SRv6 multicast endpoint behaviors. These are very similar to the N.DT4, N.DT6, and N.DT46 that's already defined in the SRv6 network programming RFC, except for the fact that the difference here is that the lookups will happen in a multicast table. Next slide, please. So while we as the co-authors, we are looking to add more content to this document, we'd appreciate feedback from the working group, and we're seeking comments at this point to help improve the document. We welcome that. And with that, I conclude my presentation. If there's any questions, I'll be happy to answer them.
Okay, thanks, Arvind. Any questions? I do not see anybody. Thank you. I think next is Human.
Hey folks, just checking, can you hear me?
Yes, I can hear you.
Thank you.
Just give me a minute to...
All right, so just to continue for the Mvpn, Evpn, SR point to multipoint, we are taking it a step further with the SR point to multipoint policy. Originally, we had this in the IDR working group. That's where the draft is, but we thought we should present it in BESS as well, because there is another presentation and another work that is trying to address the same type of transport downloading via BGP. So we wanted everybody to be in sync and understand the both methods. Next slide, please. Or do I have control of it myself?
No, it's I've done it.
Perfect. So here are the drafts that we are working when it comes to the point to multipoint, SR point to multipoint, or what we call the 3-seat. There is a replication segment that is already adopted in the spring. There is a point to multipoint policy itself, as I will go through it, which is within PIM. Again, there's a Yang in a spring, the Mvpn, Evpn. It's adopted within this working group. And there's a bunch of other ones. There's one in the PCE, how the controller downloads the point to multipoint tree into the PCC, if you will. And then there is this BGP SR point to multipoint policy, which again, as Matt mentioned, it's in the IDR, but we need to find the home for it, whether it's BESS or IDR, we need to figure that out. And then obviously there is some OEM aspects of it, which is the ping that's residing in PIM as of now. Next slide, please. So to give you a little bit of background, what is this SR point-to-multipoint policy is, you folks already know it based on the Evpn and Mvpn draft that is adopted here. But basically all it is a point-to-multipoint policy that identifies the root and a set of leaves, and it contains a bunch of replication segments. If you want to think about the replication segment, they are like forwarding instructions where they provide the outgoing interface based on an incoming seed, based on an incoming label, and there's going to be a set of outgoing interfaces that you can forward your traffic on. That's what the replication segment is, and I'll talk about that a little bit later on. It is identified by a root and tree ID, which is very common when it comes to the point-to-multipoint trees. And there's two ways to initiate this tree. So when I say a tree, obviously I mean it is a transport MPLS path, end-to-end MPLS transport. This is nothing to do with the service itself. The service writes over this. This is an underlay transport point-to-multipoint LSP, if you will. So there's PCC initiated. In the PCC initiated, the Evpn or Mvpn procedures will identify the leaves throughout the network, will communicate that via BGP to the root, and the root will use some mechanism, whether it's PCE or whether there is a hook from the PCE into the BGP session to read all that information. The controller will actually figure out where the roots are, where the leaves are, based on that MP-BGP session that is ongoing between the root and the leaves. And when it figures out the leaf and the root, it calculates the tree and it downloads it down to the PCCs. There is another way of doing it, which is PCE initiated. In the case of PCE initiate, you go on to the controller itself and you say, here's my root, here are my leaves. And based on that, the tree is calculated via whatever algorithm, SPF, whatever the algorithm is, and it gets downloaded to the PCCs via the replication segments. Next slide, please. So with regard to the point-to-multipoint policy itself, it is very close to the unicast candidate paths. So we have a set of candidate paths. These candidate paths are actually built via what we call path instances. So the path instance is actually the point-to-multipoint tree. It's the LSP itself. The reason that we have multiple path instances under a candidate path is because if you want to do global optimization, we create a second tree based on the optimized path, and we switch from one path instance to the second path instance. Now, in the point-to-multipoint policy, the candidate paths are really used for redundancy. So what that means is that there is a primary and then there's a bunch of backups. The one with the highest preference, the candidate path with the highest preference is the primary one. In this draft, as you will see later on, we actually propose ECMP2 based on the same TLVs that we are using in the unicast SR policy. So there is a weight, and you will see that we can use that for ECMP purposes. So two candidate paths can have the same weight, and they can be used in an ECMP pair, if you wish so. Next slide, please. So I already talked about this. I'm going to go quickly. When it comes to the replication segment itself, what it is an incoming label and set of instructions for outgoing OIFs, outgoing interfaces. And it's really what the instructions that are residing on the data path is. So it contains the fast reroute information as well. If you want to protect one of your OIFs, you can create a protection next hub to protect that outgoing interface. And it's really the data path instructions to forward the packet for an incoming label to outgoing, for incoming seed, I should say, because SRv6 is actually used here too, to a set of outgoing interfaces. So another point that I want to make here is that the beauty of this replication segment is it doesn't need to be, the replication segments, they don't need to be connected on every single node. They can be connected via a unicast SR segment, segment list, if you will. And that's the power of this replication segments. So you could create a replication segment on the root, if you will, and then have unicast segment routing take that packet all the way to the leaf for ingress replication, or connect two replication throughout the network via a unicast segment routing. So if some part of the network doesn't support multicast or replication segment, you can use unicast segment routing to connect these two replication segments together. Next slide, please. So this is what I already talked about. Again, quickly, the root has the point-to-multipoint policy. The point-multipoint policy resides only on the root. It is identified by the root node, leaf node, and the tree ID, by the root ID and the tree ID. And then the replication segments are downloaded via the controller, whether it's PCE or whether this is point-to-multipoint policy that we are talking about. After calculation of the tree, the replication segments are downloaded on every single node, in this case, A, C, D, and E. And in this example, B is not replication segment aware. So as you can see, replication segment A and C are connected via a unicast SR policy, whether it's SR MPLS or SR V6, doesn't matter. You can connect those two replication segments. Next slide, please. So when it comes to the point-to-multipoint policy and BGP, we try to keep the idea very much in line with the unicast SR policy. So we created a new NLRI, which is the point-to-multipoint policy, a new SAFI for that, and we created two route types. These two route types, one is used for point-to-multipoint policy, and the other one is actually used for replication segment. Again, remember, the point-to-multipoint policy is the policy on the root, which is used for steering the traffic into the tree, and the replication segments are actually the data path instructions for incoming SID and set of outgoing OIFs. Next slide, please. I'm not going to go too much into detail here. You can read the draft, but the main idea here for us was to keep the point-to-point policy in line with the unicast draft. And the reason is very simple. If there's already a code that we are using for the unicast SR policy, we just want to extend that code and to that procedures to the point-to-multipoint policy. So again, we download the policies via the candidate paths. And the path instances are, as I mentioned, there are two different path instances for each candidate, active and a standby. Sorry, there are two path instances under each candidate path for global optimization. So this, what you're looking at, is really the route type for the point-to-multipoint policy. And next slide. And this one is the route type for the replication segment. As you can see, we are using the segment list, and under the segment list, you have the different segments listed on it. We are using the weight TLV that is already there on the unicast SR policy. That is optional. And another thing that we added here is the protection on the last segment list. If you can see, there is a protection. And the reason that we added that is most of the time we can use segment routing, unicast segment routing for protection using LFA, TI LFA, remote LFA, whatever is available on the unicast domain. But there could be some cases that there are no unicast segment routing, and you might want to protect one of your outgoing interfaces via a replication segment itself. So you could create, ideally, in theory, you could create a protection LSP, if you will, via a replication segment that protects an outgoing OIF. And that's the reason that we created that extra protection TLV to protect one of those outgoing interfaces on the segment. So you can skip two slides now, if you will. So that's all about the draft, what it is. Where we are at, as I mentioned, it's in the IDR working group as of now. And we weren't sure whether this work should be in BESS or whether it should be in IDR. We are looking for adaptation, but we are looking for a home for it. We are not sure which one of the working group we should actually put the draft in. That's all I have. Question, comments, please.
Okay, thank you, Herman. I believe the IDR chair suggested presenting it over here partly because there was some sort of related work in the multicast controller draft that's up next from Jeffrey. I don't know if you want to...
Yeah, that was exactly my point. I don't know, Uman, if you already started to discuss with Jeffrey about the work that he has proposed.
We have, in fact, part of my presentation, a major part of my presentation is about the relationship between the two drafts and our ongoing discussion on what's the best way to go forward.
Okay.
Okay.
Okay, so this is an update on the BGP multicast signaling from controllers. Next slide, please. So I posted revision 07 recently. I want to talk about the main changes very quickly here, and then focus on the relationship between the two options of doing SR P2P signaling. The first big change is that we introduced a new route type, replication state, to replace the leaf AD route type. The main reason is that leaf AD routes gives you the impression that it's tied with the Bgpm Vpn, and that was kind of causing some confusion with people. So now we use this new route type. It serves the same function, and in fact, its format is also very consistent with the leaf AD routes, so that we can maintain a maximum code reuse with other scenarios. But now with this route name change, even if you don't have Bgpm Vpn knowledge, it will not affect understanding and implement this approach. The next change is to clarifications on the Bgpm and Mvpn replacements use case. Even though I mentioned earlier that you don't need Bgpm Mvpn knowledge to understand the BGP multicast controller approach. On the other hand, this approach can actually be used to replace the distributed BGP Mvpn approach. The details are in the spec. It's already in the spec in the draft before, so I will not talk about details here. And then finally, about SRP2MP signaling, Woman just gave a very good summary on what SRP2MP is and how it could be signaled using an SRP2MP policy that is very similar to the SRP2P policy. Now, another approach is in this BGP controller draft, which I call it's a Bgpm Class. So let me just skip to the some information about these two approaches. Next slide, please. So again, we have two options. One is this we call Bgpm Class. The other one is I call it SRT P2P because SRT P2P is the name that we use for P2P case. There are common grounds between these two approaches. Both will use new NLRI route types in new Sapphire to program the replication segments information onto the tree nodes. They both use tunnel encapsulation attributes, TEA, to encode the forwarding information. Next slide, please. Now, for Bgpm Class, the one thing that I want to emphasize is it covers both IP multicast, MLTP tunnel, and SRP2B tunnel, and also label identifier trees. So it's not just SRP2MP. It also supports MP to MP, and it supports SRP2MP, even though, however, the entire approach itself is not SR specific, except when it comes to SRP2MP, of course. It also supports both overlay and underlay signaling. By overlay here, I mean that it can be used to signal BGP and Vpn states onto the PEs in the VRFs. It uses TEA to encode forwarding information. Next slide, please. For SRT-P2MP, it's specifically just for SRP2MP. It does not support MP to MP yet, but I'm pretty sure it could be enhanced to do that if the lead comes. It also uses a new CFI, because we just can't use the existing SR policy CFI, even though it's using a similar approach. Human already talked about the different NRI route types to encode the forward policy and replication segment information. Next slide, please. Now, the differences between the two approaches when it comes to SRP2MP signaling. One thing is that with Bgpm Class approach, we don't use a separate routes for the policy itself. The policy information is carried in attribute that is attached to the route for application segments on the route. That is actually not a major issue, major difference. That can be reconciled. The major difference is in the tunnel encapsulation attributes. As a woman mentioned, when it comes to SRT P2MP, it's similar to the P2P case. Policy information is encoded in a tunnel encapsulation attributes attached to the route. And all the replication branches are encoded in a single tunnel in the tunnel encapsulation attribute. For Bgpm Class, in my view, is more aligned with the traditional tunnel encapsulation attributes. It does not carry policy information in the TEA. And all those branches, each branch, replication branch, is actually a TEA tunnel. I'll explain that a little bit further. Next slide, please. So a quick review on the tunnel encapsulation attributes. In the initial unicast use case, the egress router advertises a BGP route. That route has a TEA attached. That TEA could encode a bunch of tunnels. So each TLV in a TEA is a tunnel. The ingress router will resolve the routes using the tunnels instead of protocol next hop in the route update. Now, let's say the TEA has 3 tunnels in it, then the ingress router will ECMP or load balancing traffic out of all those listed tunnels. That's the initial TEA for the unicast case. Now, when it comes to SRT P2P, a P2P policy is candidate path is to a destination address, and traffic to that destination can be ECMP or load balanced out of several segment lists. So, but those segment lists are encoded as sub-TLVs of a single P2P policy tunnel instead of treating them as different tunnels in the TEA. my understanding is that this is done because the policy information has to, because the TEA's, each TLV in a TEA is a tunnel. So the policy information cannot be encoded as a tunnel. And so to do that, you have to use a single tunnel that has policy information as TLV, sub-TLVs of that tunnel. And the and other segment is also the sub-TLVs in the tunnel. Next slide, please. So when this is extended to the P2MP, a similar thing, a model is taken. So all those replication branches are encoded into a single tunnel. Next slide, please. I want to skip some details here. Now, when it comes to the Bgpm Class, each replication branch is encoded as a tunnel. Basically, it's a top-level TLV in the TEA. I have this example on the right side. For example, in this TEA, we have 4 tunnels. One of the tunnels, I should say quote-unquote tunnel. One of the tunnel is actually used to represent the upstream information, where the traffic should come from, what the incoming label is, things like that. And other tunnels are outgoing replication branches. When we encode this way, to me, it is more aligned with the initial TEA structure. And more importantly, this will simplify MP to MP feature when it is needed. Because when it comes to MP to MP, every replication branch is basically used for both incoming traffic and outgoing traffic. So if you treat it, each replication branch as a tunnel in the TEA, it becomes very easy and very natural to do that. Next slide, please. So after we noticed that we have these 2 different approaches for SR-P2MP signaling, we had some discussions among the 2 group of people, and we don't have any conclusions yet, but we talk about some possible ways forward. For example, we may be able to use a single set file for both Bgpm Class and SRT P2MP policy approach. And when it comes to SR-P2MP, we can, even for Bgpm Class, even though today we don't use a separate route for policy information, and we can also go that way, use a separate route to include the policy information instead of using using attributes. And more importantly, when it comes to encoding the forwarding information for tree nodes, we can probably use either style of the TEA. For the Bgpm Class way is that we use tunnels of basically top-level TLVs in the TEA as replication branches, or you can do it the SRT P2MP way, where we only the TEA only has a single tunnel, and that single tunnel will encode multiple downstream nodes, and for each downstream node, you can have different segments to reach that downstream nodes. That is similar to P2P policy. Next slide, please. So some considerations are here, or they could be viewed as why I think things could be done a certain way. Basically, I explain my preference here. So the SRT P2MP style TA is only applicable to SRT SR case. It's not applicable to IP multicast or MLDP tunnels. So the BGP MCAS style TA is needed anyway, and it can be used to cover all situations, including SRP to MP. So from that point of view, I would think that it's better to just use one single style of TEA here, which is basically BGP MCAS style TEA, because it can do all the things that we need to do. But now, why I can understand that why we want to retain the SRT P2MP style, because if you don't care about other scenarios, like you don't think you ever need IP multicast or MLDP tunnel signal from the controllers, and you only care about SRP to MP, and you already have the SRT P2P implementation, then going with the SRT P2P style is fine. I do want to point out that that means that we have to duplicate the effort in both standards and implementation, as long as we need to support controller signal IP multicast or controller signal MLDP tunnel. So from that point of view, I would prefer to have a single style, but I'm fine with keep supporting both styles. So now the next question is, do we want to have a single document to cover both, or just keep them separate? Because the only difference here is just the style of the TEAs. Again, my preference would be to have a single document, but I'm fine with having a separate to keep them separate. It's up to the working group to decide. So this is my consideration or my preference here. Next slide, please.
Yeah, we are getting out of time, Jeffrey.
Yeah.
If you can conclude very quickly.
Yes. So we don't have any conclusions yet. We want to see comments, and I do want to point out that the BGP MCAS spec can and should proceed on its own. It is self-sufficient and cover all the scenarios, but while it's proceed on its own, we will have the considerations for sharing CFI and route types with the SRT P2MP, and with consideration for potential merge from that the other approach. That's just that's about it. Again, we want to seek comments from the working group.
Okay, thank you. Susan, you were first in the queue.
Comment toward the last one and toward this one, toward new NRIs that are more than just a prefix. You will find in my review today of another draft, I noted that we found some errors with RFC 7606 with the error handling that aren't, excuse me, some errors with the embedded NRIs, that is the NRIs with a route target or something in front of them passing through that did RFC 7606 doesn't really cover. The IDR chairs are suggesting that we might want to have a generic discussion of that in IDR so that all these drafts which are working on this can handle the error processing in a sort of update to 7606. That is why the previous authors may have heard the suggestion to go toward IDR. We can continue to work on this with the best draft. Jeffrey, I think we've talked about this personally, so I'm not going to target any additional stuff for yours. Thank you.
Thanks. Herman.
Actually, I think maybe Susan address some of my question. I think as Jeffrey said, one draft is just the underlay, the transport, and the other one is overlay and the underlay. And just one other point for everybody, I guess, to consider is the BGP multicast draft, since it's addressing underlay and overlay, it is already heavy draft. There's a lot of information in there. So that was another consideration that we should take, assuming we want to go with the two different ways of doing this, just because one is very closer to point-to-point SRTE policy, and we want to keep that mechanism for multicast as well. Then coming up with a single draft, it just becomes a question that how digestible is that single draft if it's cramping the overlay, the underlay, multiple ways of doing the underlay. It becomes a hard digesting type of draft.
So my comment about that is that overlay underlay, the BGP multicast draft itself is actually does not make any difference between those two. It just happens that the same approach can be used for BGP and Vpn as well. If you put that aside, all you say is how do you use BGP signaling to set up multicast forwarding state. So overlay underlay, there is really no difference. And as whether which group is best for this spec, because of overlay and underlay difference, I think I probably don't have time to explain why this was started in the BESS working group, but I'll send out email explaining the history on this.
For the chair's comment, my comment about error handling was independent of underlay or overlay. It's about getting the right error handling to work for the BGP protocol. So I'm not suggesting one is better than the other, or this doesn't apply to both. It does apply to both, that we want to get the error handling when it passes through BGP right. Thank you.
Okay. Kia, can you make your comment very quick, please? And then I think we need to cut the line because we're running about 10 minutes over.
We are really out of time, Matthew.
Sure, I will be super quick. Hey, Jeffrey, I have to yet go through the detailed sections of the draft, but I think one couple of things here, and I'll send you the comments as well. The fan out is something typically when you have a direct BGP connections with the controller becomes somewhat of an issue. And I don't know how you're planning to handle maybe some text there. And then if this is going to be a direct BGP connection with single hop, I also don't know what you have done in here to prevent flowing of these updates from one BGP connection to another. I am assuming because you're using SRTE, all the rules, or rather that SAFI, all the rules apply here. Thank you.
A very quick response. All you need is one BGP connect session from the controller to one of the speakers in the network. You can have two for redundancy, but otherwise you only need one session.
Okay, folks, thank you very much. I think we need to move on now. Next one's going.
All right. Can you hear? Hi, my name is Gian Mishra, and I'm with Verizon, and I'm providing an update for the draft IPv4 NLRI with IPv6 next hop deployment guide. Next slide. Thank you. So the latest updates in the draft. So this past spring, the draft was adopted on April 28th. So we got a lot of good feedback during the adoption call. So from the feedback from the adoption call, one of the main key points I think was clarifying, I think, the goals of the draft, which were updated, as well as IPv6 only, the IPv6 only PEC peering architecture and design framework, where we have IPv4 and IPv6 forwarding, which occurs as it did before with the traditional dual stack peering, but now without an IPv4 address defined on the PEC attachment circuit. So that was clarified in the draft, as well as added some slides in the draft related to the V4 and V6 forwarding occurring with a single V6 address on the PEC attachment circuit. We had an update to the co-author from Juniper. Lily Wang was dropped off, and we added Sudha Madhavi and Mohana Sundari. So in June, after the adoption call, we had a meeting with all the co-authors from each of the vendors, so Cisco, Juniper, Arista, Nokia, and Huawei. And we did a deep dive into the architecture and the IPv6 only peering design, and came up with 4 test cases, and we'll go over that in the draft, in the presentation. We also created a detailed test plan and a test lab document that would kind of show really the architecture that we would be testing, and just kind of making it the same vanilla, same topology for each vendor to test, and as well as protocols that we would test, and then the goals of the testing. During the meeting, we did also investigate interoperability testing between vendors, and kind of the caveats related to interoperability. And we also threw out an idea of possibly testing through IETF Denmark to do interoperability testing, since they have a lot of the 5 vendors that we have in this draft. They're also there at IETF in Denmark. So I took the lead on that through our Verizon engagement with IETF. And we also, I guess, another big update in the draft is we nailed down the vendor platform. So we'll go through that in the code revisions for the testing. As far as the IPv6 only PEC peering interoperability testing status, so when we investigated that in June, when we met with all the co-authors, we discussed the feasibility and practicality of interoperability testing. I think that really the biggest thing was logistics, shipping hardware to a central location, and that's where the idea of using a third party like IETF to test. So first we looked at, so we did actually also talk about possibly doing virtual, but due to caveats and issues related to not having physical hardware, the results of the test would not be as accurate. So we scrapped that idea, and we all came to a consensus that we definitely need physical hardware. So from looking at the IETF option, since the test was in July, and we really had such a short time frame, and we hadn't done the prerequisite testing at that point, it just wasn't feasible. This time frame was impossible. So we decided that we can accomplish basically the same goals that we plan to do with the IPv6 only peering, the architecture testing, the end-to-end testing with the 4 use cases that we put together, that we can do that per vendor. So it'd be vendor-specific testing. So we would be able to accomplish all the same goals. And really the goal is that after this draft, testing is completed, and this draft gets published, that other vendors, that are not part of this test, that they'll be able to look at the draft and be able to implement the solution as well as operators around the world can take advantage of this. And I do plan to take this up in GROW, as well as the routing working group, and probably submit a draft to talk about IPv6 only peering, as well as take this up with the operator working groups, NANOG and whatnot, as well as other working groups to actually help with the proliferation of IPv6 only peering. Next slide.
Actually, Guillaume, can I ask you to maybe skip to the main points of the presentation?
Sure.
You have 23 slides for 5 minutes.
Yeah, sure.
Thank you.
Understood. We'll go through quick. So basically the 4 test cases we have, so it's, the first test case is end-to-end IPv6 only peering PEC, so global tabling over a v4 core, then VPN over a v4 core, so v6 only peering, VPN over v4 core, then test 3, case 3 is IPv6 only PEC, and then global over a v6 core, and then the same VPN over a v6 core. So those are really the main 4 test cases that we have. The one additional test that we're going to test in all 3 cases is when we're doing the IPv6 only, I guess an operational consideration with ping and trace route, just ensuring that all the ICMP types and codes work properly, as well as when you have a route withdrawal that happens off of let's say a route gets withdrawn and an ICMP is sent that the P has to originate. How would it originate that, not having a v4 address? So we came up with an idea that we would possibly plan, and this is what we'll test, is we would put a loopback, a v4 loopback on the PE, so you can originate that that ICMP response back towards a CE with that loop. So below are the platforms. So we nailed down all the platforms for Cisco, Juniper, Nokia, Huawei. Arista is the only one that we're still waiting on feedback on. And then we did some preliminary testing with Juniper, and that went well. Looks like there were some code issues on 20, 20.4R2, but when they tried 21.4, everything worked. So far so good with the testing, and we'll keep the draft up, updated with ongoing testing that happens. Next slide.
Yeah, Gian, I'm sorry, but we have to move on. If you can conclude in 30 seconds, because we are already running late, and you had just 5 minutes.
Okay, no problem. All right, I think I've gone through the main. Yeah, I'm all set. Thank you, Matthew. I'm all set.
Great, thank you very much. These slides are available on the meeting materials, so folks can go through them, all the detail on these slides. That's really great information. Thank you.
Thanks.
Okay. So next up is Jorge.
Can you hear me?
Yes, thank you. It's lots of clicks to share anything. Yep.
Thank you, Matthew. Hi, everyone. This is a short update about the multicast source redundancy in Evpn networks draft. Can you go to the next slide, please? Yeah, short agenda. Gonna talk about the changes in revision 1 and next steps. Next slide, please. Yeah, short refresh. This is about having a multicast redundancy solution with redundant sources connected to a different or same PE, and being those sources a single home or a multi-home, same or different broadcast domain. And here we introduce the concept of the single flow group, which means that the multicast stream is sourced from different source IP, but the actual content is the same. So this solution actually finds a way to avoid packet duplication and provide the redundancy needed. Next slide, please. The draft was already adopted. We already discussed it a number of times. We incorporated feedback from the working group. So this revision, what it's doing is fixing a few typos and minor things, and adding a new section 5.1 that is talking about the advertisement of the DCB labels. The DCB labels, or domain-wide common block labels, are used in the one of the solutions in the draft, in the hot standby solution, and this is used to identify the traffic coming from the Ethernet segments that are attached to the redundant sources. The reason why we needed this section here is because the Mvpn Evpn accreditation label draft, which defines the DCB labels, assumes that these DCB labels for Ethernet segments can only be used in a very limited number of cases. So in this section, basically, we extend the use of DCB labels so that they are completely independent of the PMSI label that you advertise in the IMEC or SPMC route. So now we can use it along with interception PMC trees, and they can be used even if the the PTA attribute does not use a DCB label. Next slide, please. So we're still seeking for more working group feedback. And then we realized we need to add some more clarifications about the use of context label space IDX in the communities along with this draft, because there were some things that were not 100% clear. So we will do that. And after that, the document will be closed to be done. And that's it.
Thanks. Any comments on that document? Let's move on to the next one then.
Thank you, Matthew. So the next one is the Evpn IP aliasing draft. Next slide, please. So we'll talk about three things: short introduction, the use cases that we are covering in revision 2 of the draft, and conclusions and next steps. Next slide, please. So the draft version 0 was presented by Ali in IETF 99, and it was at the time an extension of the Evpn aliasing procedures, but in this case for the Evpn symmetric IRB model with the Evpn MAC IP routes. Then we added in version 1, we added support for Evpn prefixed routes. And in the current revision 2, we are clarifying especially all the is related to IP prefix routes. And also we are clarifying how you construct the IP auto discovery per ES and per EVA routes. Next slide, please. So this is just a short refresh of the RFC 7432 aliasing procedures at layer 2. So when you do it at layer 3 is pretty much an extension of this. So if you look at this diagram, basically the 3 leaf routers are attached to the same broadcast domain. And then you have leaf 1 and 2 attached to the Ethernet segment 1. So when CE1 sends some traffic, we learn the MAC address on leaf 1, for instance, due to the hashing. Now leaf 1 will advertise a MAC IP route with the Ethernet segment identifier and the next hop. But at the same time, you have both leaf 1 and 2 advertising or indicating that they are attached to the same Ethernet segment. And for that, we have the AD per ES and per EVI routes, as you know from 7432. Now with those routes, basically leaf 5 is able to install MAC1 associated to an Ethernet segment destination that is resolved to leaf 1 and leaf 2. And at the same time, leaf 2 also receives the MAC IP route with the Ethernet segment and is able to install the MAC associated to the local Ethernet segment destination. So this is pretty much the RFC 7432 aliasing procedures. So in the next slide, please, we are explaining that when you do the same thing for a layer 3 environment, basically the procedures are pretty similar to the layer 2 case. In this case, you have the 3 leaves they are attached to the same tenant, so they have an IPVerf configured. And leaf 1 and leaf 2 are attached to the same broadcast domain where the Ethernet segment is hosted. The difference here is that leaf 5 on the IPVerf has an IRB sub interface, which is attached to a different broadcast domain, right? But we are able to, using the MAC IP routes with the Ethernet segment, according to the symmetric IRB model, these routes are now advertised with not only with a layer 2 label, but also layer 3 label, and not only with the MAC VERF route target, but also the IPVerf route target. So with that information, we are able to install that, as a host route in the IPVerf of leaf 5, and also we are able to synchronize that on leaf 2 in the IPVerf. So what we are doing here, which is new, is there are also AD per ES and per EVA routes being advertised by leaf 1 and leaf 2, but we want those to be installed and imported on leaf 5 IPVerf. So in order to do that, we attach also the IPVerf route target. And then with that information, leaf 5 is able to install the host route associated to an Ethernet segment identifier that is resolved to the two leaves, leaf 1 and leaf 2. And similarly, leaf 2 can also synchronize the host route. Next slide, please. A very similar scenario is if you use the Ethernet segment in the same kind of environment with the same services and MacVerfs and IPVerfs configured. But now if you use IP prefix routes, so routes type 5, you can actually use the same concept. So now when you learn the MAC IP of the host behind CE1, you populate a host route in leaf 1, you can advertise IP prefix route also tagged with the Ethernet segment identifier, right? And we do the same thing with the IP AD per ES and per EVA routes. So we add the IPVerf route target so that the routes can be imported by leaf 5. So in the same way, we can actually, in the IPVerf of leaf 5, we can install the prefix associated to the Ethernet segment that is resolved to the two leaves. And similarly, we can do the synchronization in leaf 2. Next slide, please. And finally, the other use case we wanted to address with this draft is when you have the Ethernet segment purely as a layer 3 construct. In this case, the Ethernet segment is not associated to a group of links, of physical links, but it's a virtual Ethernet segment associated to the loopback of a multi-rack VNF that is attached to a bunch of leaves. So in this case, in this use case, this is a multi-rack VNF attached to 4 leaves, but the VNF only supports 2 BGP sessions to advertise the prefixes behind the VNF, right? But we still want leaf 5 to be able to ECMP the traffic that it receives with an IP destination address to the 50.0 subnet. We want to have ECMP to the 4 leaves. And for that, we make use of this IP aliasing mechanism as well. And in the same way, we also need to synchronize those IP prefix routes in the leaves that will not receive those prefixes directly. And we do that via the Ethernet segment identifier as well. Next slide, please. So basically, you can read all the details in the draft. And basically, we really would like to ask for working group adoption after the discussion, proper discussion in the working group. That's it. Thank you.
Patrice.
Hey, hi, Patrice from Cisco. Hey, how are you? Quick question about 6 or 7, I think it's pretty much the same diagram. If you can go there, Matthew. Yeah, I can see this as a natural evolution of what we have been doing right for a while. And thanks for that, Jorge. One of the questions I have for you is on the leaf side at the top of the slides. Why do you need a bridge domain there if this is purely for layer 3? That one I don't get it.
Well, you may or you may not have a bridge domain, right? I mean, this is part of a typical data center where you have bridge domains. You may have some other hosts connected to the bridge domain. Right?
So you're gonna have a stretch, an L2 stretch. It's just because it goes against the purpose a bit of what you're explaining. If you're also adding a layer 2 stretch over that cloud as well, that's pretty much the confusion I guess it's making to me, honestly. I would have expected the leaf at least to be an L3 device because that's L3 that you're explaining, I guess.
Yeah,
or
I mean, you can always have a purpose. Yeah, you could have also a broadcast domain with a single IRB and a single interface if you want it, right? That's it's a generic model.
Okay, but it doesn't serve any purpose here on your explanation. That's what I'm trying to understand.
I mean, if you mean that we could have used an IP interface on the IPVerf directly, I guess. I mean, I saw the other draft that you guys have about the layer 3 lag and all that, but I mean, this is not really the use case we are trying to address here.
Okay. Another maybe ask is, can we rename this draft to something more explicit than IP aliasing? I think now with the latest add-on, yes, IP aliasing is covered, but there's more than that, I think. So maybe
actually,
a rename of the draft will help.
The name of the draft itself, because after the last bunch of edits that John, especially John, made, we actually changed the title. If you go into the draft now, the title is probably more precise. If we can change the name itself, yeah, I'm not sure. Probably it's a bit of hassle, and especially if you are following up on the draft.
Yeah. Okay. Thanks.
Yeah. Thank you.
Okay. Thank you. Patrice, you are next up.
All right. I'm Patrice, Cisco System. So today we're going to just go over three drafts. So Matthew, are you going to share it, or you want me to share?
Yeah. It just takes.
Okay, sorry.
Quite sorry. Again, no, it just takes an awful lot of clicks in Meet Echo to do this. There you go.
All right. So this first one, which is Evpn AC-aware bundling, it's we put an updated version recently on behalf of these authors, Cisco and Nokia, Juniper, and it's been reviewed also by everyone on the parties. I guess if we go to the next slide, I think just a quick refresh about what we are trying to achieve here. All right. So basically, it's really a problem when you have Evpn with symmetric IRB and you have multiple VLANs, right, coming from the same ESI inside your bridge domain. Like I showed here, you have bundles, right, feeding two different routers, and they all have VLAN 10, 20, and 30 feeding that bridge domain. So you will see that there's like packet coming from the CE, go to the left side, and will get learned and sent over the IRB towards the guy at the top, right, with the broadcast domain D3. And what is happening here is that we're going to be learning the MAC, right, and inside the B1, and we're going to say, oh, that MAC is associated with the B1.1. And usually speaking, whenever you have an ESI, you're going to start doing synchronization of data, like your ARP and stuff like that, across the viewing PE. So therefore, here what you're going to be seeing is that, usually speaking, the MAC that you're going to be synchronizing will not have the vid. What I put here in yellow is usually not there. So therefore, when the MAC is getting on the other side, you have no clue to which bridge port it belongs to. The only thing that you will know is the ESI. And whenever you're updating your MAC forwarding table, you won't know, should I point to a VLAN 10, a 20, or 30, because all the traffic coming from your RRB is untagged. So as soon as you have traffic north-south, well, basically the right side would not get resolved properly. You have no clue where to go, and that would not work. So what this draft is doing is just adding an XCOM to the route to specify to which VLAN that MAC is belonging to. So therefore, if you're following what I've put at the bottom of the slide, it means that whenever I do my synchronization, and yes, I belong to XYZ, which is the B1, but also I belong to VID10. So therefore, I can put the MAC1 and B1.1 on the right side of the bridge domain, and you can just forward the traffic from the RB to the right things. So that's pretty much what this draft is about. So next slide, you can skip it. I said there was a problem here in the in the order of the slides, so keep moving. Okay, let's go to the next one. So as a next step, so we are shipping, Cisco is shipping this solution to several customers, and it works very, very well. It's also like a multi-vendor draft. So what I would like to see is if people has more comments and also work group adoption. It's kind of well overdue. Question, Swadesh?
Go ahead, Swadesh, if you...
Swadesh? All right, okay, let's keep moving then.
Yeah, sorry, are you able to hear me now?
Yes.
Yeah.
Sorry, yeah, I was speaking on mute. So isn't this an errata for the base draft? Even though it proposes that service, it will not work in such environment, or do you think it's a new draft? That's the question I have.
Yeah, good question.
So let me take that. May I take that question?
Yeah, please, Ali.
This is not errata because this is basically a new service interface type. Instead of before, we had a VLAN aware bundle service that per VLAN, when you advertise a route, it puts that into the different broadcast domain. So VLAN in Patrick's example, VLAN 10, 20, 30, each would go into the different broadcast domain. What we want to do in here, we want to treat the VLAN not as a broadcast domain, but as a sub-interface, and be able to identify the packet, which sub-interface it is coming from, and put it into the same broadcast domain. So VLAN 10, 20, 30, in Patrick's example, they're all associated with the same broadcast domain.
But isn't that one of the services defined in the base draft? Also, there were three services. One was your VLAN specific, as you mentioned. VLAN identifies the broadcast domain. But another service was that you can have multiple VLANs in the broadcast domain as well. Just a curiosity. I'm not sure if that's the case. Then I'm fine. Ali.
No, but in that one, the VLAN is basically the VLAN would be opaque. So you're right. I mean, there is another one that we put on, and it's called VLAN bundle service. So there are three services: VLAN base, VLAN bundle service, and VLAN aware bundle service. With the VLAN bundle, you put all the VLANs into the same broadcast domain, but the VLAN is opaque. You don't care about the VLAN. You don't look at the VLAN. In here, we want to look at the VLAN and say this VLAN means this sub-interface. So that's the difference.
Okay.
If my explanation is not clear, we can, you can.
Yeah,
send
Ali, I'll ping you. Yeah,
sure. Sounds good.
All right. Anything else on this one? Or we can move forward?
There's a question from Wen.
clarification. 3 different VLAN, they share the same bridge domain, but each VLAN still have their own broadcasting domain, right? You mentioned that they share the same broadcasting domain, but I would think they still have their own broadcasting domain, but they share the same bridge domain. Just to want to see.
So the broadcast domain can be represented by multiple VLAN IDs.
Yeah.
Okay,
Yeah.
so you're right. I mean, if I say VLAN, I mean VLAN IDs. So it is the same broadcast domain, but represented. The VLAN IDs in here basically identifies the attachment circuit as opposed to identifying a broadcast domain.
We are not create a different service type. It's still, this is really more about VLAN bundle service, right? In this.
Say that again.
This is more about VLAN bundle service.
This is about VLAN. This is about having basically optimizing the number of the MAC addresses that you want to keep in your bridge table. Instead of creating 3 different bridge tables, you can have one bridge table, one broadcast domain for one bridge table, and use each of these VLAN as a sub interfaces.
It is a same bridge table, same bridge domain, different broadcast domain. Anyway, so I think, thanks.
Sure.
All right. So the second one here is the Evpn Vpws seamless migration. So, okay, so this is a very interesting one, and you can see there's a lot of people who help and contribute to that draft. So thanks to everyone. It's many people from Cisco, Juniper, Nokia, and then many vendors also who sponsor us. So AT&T, Bell, LinkedIn, Verizon Wireless, and Comcast. So next slide, please. So, okay, so just to tell you what happens, right? So about, well, it's a year ago, pretty much, right? There were 2 drafts being presented at the IETF. Like they were, and so there was one from my side explaining how Evpn VPWS for BGP AD and LDP will work. And there was one also coming from the Juniper folks stating something very similar, but just for BGP AD. So the consensus was to merge these 2 drafts into a single one, because there were a lot of similarities, a lot of commonalities as well. And the merging happens over, well, since the last IETF, basically. So I took the lead on that, and with the help of other parties, I think we got something pretty good for now. To be honest, I think it's a very good draft. So I will, as a next step, I will ask everyone to go over it and read it. I think it's worth it. One thing that you will not see is all the VPLS side, because there's already an RFC and yet another draft about it. And in my mind, I really want to keep the 2 very separate, like we've done for RFC 7432 and the RFC 8214. So next slide, please. So the solution has been shipped to customer and by also multiple vendors. I know that. And it's also sponsored by operators. So guys, please comment on it. And I'm really looking for a work group adoption. Any question about this one?
Can we take any discussion to the list, please? Because we're really out of time on this one.
Okay. So the last one. So next slide. So fast DF recovery again. 3 vendors, Cisco, Juniper, Nokia on it. So next slide, please. Perfect. So the initial proposal, there was 2 approaches being discussed there or being explained. And approach 1, which was a de-application handshaking. So there was an FSM being used to speed up the recovery after failure with an Ethernet segment. And the second approach was more like simpler, which is the NTP-based synchronization solution. So what happens is we've done a lot of study here at Cisco, and we find out that the approach number one is totally a non-viable solution as it was. But the NTP-based solution we provided, and it's already in our shipping product, and it makes a huge of sense. It works like a charm. So what we decided is I asked, you saw it on the alias, and also I asked the other vendor if we can just take out the approach number one and move ahead with the NTP-based solution, which is very simple, to be honest. And people accepted. So there was no objection on the alias. And so therefore, I just updated the draft, take it out, the approach number one, and explain it, and just move forward with number two. So that's what this is. Next slide, please. So again, shipping solution for us, we are already multi-vendor. So, and this draft has been there already for a long time. So seeking for comments, and if things are good, we just ask for work group last call. That's it. Any question?
Thank you.
No problem.
Oh. Okay, thanks, folks. Right.
Michael, I think you are the next one.
Hi, am I audible?
Yeah, and welcome.
Oh, thank you.
Your first presentation, isn't it?
It is, yes. First time joining and first time presenting, so yeah.
Good luck.
Okay, hi everyone. My name's Michael McKenzie from Cisco. I'm going to be presenting an introduction to the Evpn multi-homing support for L3 services draft on behalf of the team mentioned below. Next slide. So the purpose of the draft is to try and bring the network availability and load balancing benefits of Evpn's MC lag to various L3 services, such as BGP L3 VPN. We want to use the Evpn MC lag to provide a standards-based per interface all active redundancy, and also its advantages, like removing the need for an ICL link and bringing support for fast convergence with mass withdrawal. This will be transparent to the CE devices, and it's going to leverage the BGP control plane that already exists for the L3 service advertisements. We'll use a combination of the ES import route target and the EVI route target extended communities to make sure that BGP will only import these layer 3 sync routes on the PEs, the service PEs that are attached to the same ESI and have the same EVI. There's no need for remote PEs to support Evpn or be Evpn aware. And we'll be synchronizing ARP ND entries, IGMP join and leaves, and customer IGP routes. Next slide, please. Okay, so here's an example of the sort of network topology that in the draft that we're targeting. We have two service PEs sharing a common main interface towards the CE, and the CE sees this as a lag interface. The CE device can be layer 2 or layer 3. The service PEs are going to be advertising and attracting traffic to the same L3 VPN routes to remote PEs. This could be over any of the underlays and overlays mentioned here. We will create an Evpn instance per layer 3 VRF, and these can be marked as route sync only. This means that the layer 3 VRF can be derived from the EVI value. The main interface will be associated with the ESI value. And in the case of multiple subnets over the same main interface, we'll use an attachment circuit ID extended community so that we can map the sync routes to the proper VLAN subinterface, which was just explained by Patrice in a previous draft. Next slide. Okay, so this slide tries to describe the different route syncs that are going to be required and the route types that we'll use to do that. So for example, in the case of the BGP L3 VPN, both these service PEs will be advertising the local routes towards the CE. This gives load balancing through BGP multipass support, but it means that each PE now needs to have the adjacency information in order to forward the packets. And with the hashing rules of the CE, it could be that only one service PE will hear the ARP ND responses. So we'll use a route type 2 IPMAC to synchronize these ARP entries or ND entries between the two service PEs. Because this is a route sync only EVI, really MAC only route type sync is not needed. Similar for multicast services, the hashing rules mean the CE may only provide IGMP join and leaves to the non-multicast designated router. So we'll use the route type 7 and 8 to synchronize these IGMP join and leaves between the service PEs. This will allow the designated router to do the PIM join. It also improves, in case of failover, we have these pre-populated on the other PE. And the final case is if there's an IGP between the customer CE and a single service PE, there could be a benefit if we have the customer learned routes to be synced to the other PE. That allows the second PE to advertise this to remote peers and provide load balancing as well as faster convergence. Next slide. So we're using extended communities that have already been defined in other drafts. We're using the EVI route target extended community in addition to the ESI, the ES extended community, so that we can limit the signaling to just the service PEs. We want these sync routes to only make it to PEs that are attached to the same ES and have the same EVI configured. And we're using the attachment circuit ID extended community as defined in AC aware bundling, so that we can map any of these ARP entries, ND entries to the proper sub interface over the main ESI interface. And next slide. Right, so the advantages we see is we're looking to have an open standard-based per interface all active redundancy, removing the needs for some of the legacy solutions. It provides the benefits of fast convergence and mass withdrawal. It removes the need for an ICL link. And this solution's agnostic to whatever the underlay we're using, MPLS, VXLAN, SRv6, or the service that's running on top. L3VPN is the main service we're using as examples in the draft. And the signaling we need are already defined in the Evpn RFCs and the following drafts. And next slide. So we're requesting the work group to provide some feedback. We're interested in any ideas and questions. We can answer those as well. And we also want to do some further study into, instead of just an IGP, if we have BGP running between the P's and C's, how to support that. And then I open it up to questions.
Well, Matthew, I'm not sure that we have time for questions. We just have 10 minutes left and one slot more.
Yeah, okay, could you take it to the list, please? I think any further discussion on this should be on the list due to our time constraints. Thanks. So the last one I think we have time for is Kaliraj.
Hi, Matthew. Can you hear me?
Thank you. I'm just getting this in this shared. There we go.
So yeah, so what I'm going to talk about today is mechanism to solve two problems in seamless MPLS networks. One is the scaling, the other one is like convergence. Next slide, please. So just like I explained just now, there are two problems, scaling and the convergence in large MPLS, seamless MPLS networks. And the solution is based on a new address family in BGP called MPLS namespaces. Today, we have like three options for doing inter-AS options, so option A, B, C. So this is, you can consider it as a combination of option B and option C. So we'll discuss how it works and the advantages. Next, please. So the goal is, so basically in any seamless MPLS network, the LO0 or the loopback of every PE is actually reachable on every border node that does next hop self. And we have MPLS route and next hop scale on all the border nodes and ingress service nodes proportional to the number of nodes in the network and also ECMP across them. So the goal is to reduce the number of protocol next hop that are visible to be a function of the number of regions instead of the number of routers itself. And this will improve the scaling properties of the border nodes and service nodes as a whole. And it also improves the convergence properties of the network by detecting and repairing traffic much closer to the failure. So that failure does not propagate end to end. So following two slides, I just have an example of the topology that we're going to follow. Next slide, please. So here we just explain what is the scale problem. So basically we show here an example of region 1 and a remote region 2. And region 1 has like 100 PEs, which may have some service deployed on them. And it is advertising the label VL5, for example, with the loopback of PE1, and the label to reach the PE1 is the LPE1. And this goes up to PE2, and PE2 sends information, the packet. So the packet is shown at the bottom, and we do next hop self at the border nodes BN4, BN2. So here we see that PE2 will have to have the forwarding state of all the 100 PEs, and as well as the BNs. So this is the explosion of scaling problem. Next slide, please. So here it just explains what the convergence problem. When PE1 goes down, the withdrawal that PE1 has gone down has to propagate until PE2, after which PE2 can do a pick repair to choose the PE2 prime will choose PE2. So how do we shorten this convergence time so that repair happens at BN1 itself? Next slide, please. So the solution is basically a new family called MPLS namespaces. It is nothing but an L3VPN like family which carries MPLS labels instead of IP prefixes. So instead of IP VRFs, we have labeled VRFs on the border nodes. And using this, we do upstream allocation of labels in the MPLS context tables. So instead of, we get predictable label spaces at an upstream node by following Bgp MPLS procedures. And this family needs to be negotiated between just the service RR of the region and the border nodes in the same region. And no other changes are required in the rest of the network, including the PEs and other remote PEs. And what it does is a region is abstracted out by one context protocol next hop instead of N protocol, NPE LO0s. And when we are doing the advertisement, the RR does label change to a private label context and changes the next hop to the context protocol next hop. Let's go to the next slide and explain with the topology. So here we see that PES, PE1 to PE100, they have advertised the real whatever labels that they advertised today. And RR is actually changing the next hop. It's rewriting it to CPNH1. So CPNH1 is the context protocol next hop that identifies this specific region. And BN1, BN2, they advertise a context label to CPNH1 in some transport family like LU. And what that label does is, that label, when it reaches BN1, BN2, it does a lookup in the context protocol context table, CPNH1.MPLS. So now any traffic that PE2 prime is sending towards the CPNH1 will hit these context tables. And the RR, it actually installs predictable routes. For example, it can infer that CE1 is connected to BP1, P2. When it receives these routes from CP1, P2, it can advertise the same label towards CPNH1 .MPLS table in BN1, BN2. So in a way, we have done what we would do with option B, where we are doing next hop self at the border nodes, but we don't have any service routes at the border nodes. and we get predictable label assignment in both these mirror tables. So even if the PE1 fails or BN1 fails, the repair can happen easily. And the remote region does not have state for 100 loopbacks. It only has state for 1 loopback, which is CPNH1. So that is the solution for the scale. Next slide, please. So this shows how the failure is absorbed. So basically at BN1, if you see the PLCE1, that is the MPLS route, labeled route in CPNH1.MPLS. That is a private label that is allocated by the RR and upstream allocated installed in the BN1 and BN2. So the same PLCE1, it is having a primary next hop towards PE1 and backup to a next hop towards PE2. So next slide, please. So when PE1 goes down, just the active route, active leg takes over, because BN1 detects it's within the same region as PE1, and it's able to detect quickly that it is PE1 has gone down, and it is able to repair traffic. Next slide, please. So if BN1 goes down, then also the traffic that is coming will go to BN2, and it will hit the same label PLCE1. So because of which the traffic repair will happen. So there is no convergence event that needs end-to-end propagation. That is the whole advantage of this. And we see that the software changes required are only on the RR and the border node, and the whole network gets the benefit. Next slide, please. Yeah, so these are the advantages. We get the scaling, and we get the topology, basically convergence advantages, and it is actually service family agnostic. So that services that are deployed on the PEs, they can be L3VPN, L2VPN, or anything that binds services to labels and protocol next hops. And so it will work with legacy PEs also. And it will work with any transport family that can advertise this context label. So it looks like there is a lot of advantages to this mechanism. This cannot be solved by any other mechanism that I know of. So I just want to put my ideas in this draft and present it to the working group so that you can go through and give feedback, collaborate. I think that's the end of my presentation. If you have any questions. Yeah.
Swadesh, I think you were first in there. And just a warning, I'm not sure if we're going to get kicked off in 2 minutes. So make the comments very quick, please.
Yeah, maybe then I'll ask later if because I don't think it can be resolved in 2 minutes. It will take a long.
Maybe you can take it on the list.
Yeah, that makes sense.
Ali, can you make yours quick? Or?
Yeah, my question should be quick. So in the border node, under option C, border node are not VPN label there, but under your proposal, they are VPN label there. Is that correct?
So they will have state that is proportional to the service label. Yes. So they will have the state.
Yeah.
Yeah, but they will not have any service route state.
Yes, they don't, but they have label a state which they didn't have before. So I haven't gone over your draft, but if it is not mentioned there, I think it's worth mentioning in there.
Yeah. Okay.
So in other words, the way I look at it, your proposal is somewhere between option C and option B.
Yeah, right. That's why I called it option B.
It would help to elaborate on that in your draft.
Okay, yeah. So it just gives the advantages of option B and option C without having the additional scale, and also gives the convergence advantages because we are able to mirror the labels.
But I'm saying that there are a scale ramification with respect to the VPN label estate. So it's not for free. It is not for free,
The amount of VPN label state that we will have there, I think it is proportional to the service routes that this region needs. So it is normalized by using route target filtering like mechanisms. So it automatically provides on-demand next hop.
Okay.
So only if I need the service route, I will have that. Yeah.
I mean, I'm sorry, your voice came up choppy, so I couldn't hear quite what you're saying, and our time is up, so maybe we'll take it.
We can take it on the list.
Yeah.
Thank you.
Great. Okay.
Thank you for the opportunity.
thank you very much, everyone, and hopefully see you. If not, then hear from you at the next IETF.
Thank you. Bye.
Thank you.